In this lesson, we're going to be discussing relational operators. Our lesson objectives: learn the different relational operators and learn how to utilize the relational operators themselves. Alright, so this is a little cheat sheet that I provided that has all the relational operators. But before I talk about each and every single one of these operators, I need to talk about the primitive type Boolean. So as I told you before in the previous section, a Boolean value is simply true or false. And although our sort of output in regards to the Boolean value has been confined to simply just printing out true or false, or just assigning the value true or false to a Boolean value, the functionality regarding it is a lot more, let's say, powerful, because in the computer, we need to give it some sort of way of making a decision. We want it to take different paths regarding or taking account a certain context. So a true or false value allows the computer to make a decision. For example, if a certain value is true, right, the compiler is probably going to be like, all right, let's pursue this. But if something is false, then it probably will pursue something different. So although we've simply been assigning true or false to Boolean functions and have been just printing out true or false within our compiler, there is a much more powerful application regarding Boolean values that will go further in depth later in the section. However, we need to figure out different ways that we can assign values to the Boolean value, and that is where operators come in, because they play a fundamental role in providing a context, providing a sort of environment that allows the computer to make a decision. So one of the first steps we're going to take is discuss the relational operator. The first relational operator is the double equal sign, or the equal to. And basically, it compares two values, two integers, two doubles, and our application regarding that allows us to say, hey, if these two numbers are true, if these two numbers are the exact same number, then it will assign true. Whereas if the numbers are not equal to each other, then it will be false. So if we look at this function over here, let me get out my pointer. All right, so let's say a is 50, right? So I declare a variable before this, and it's called integer a is equal to 50. So when we call out integer a in this declaration, or rather assignment thing here, it's going to be like, all right, a is 50, and is that equal to 50? 50 is equal to 50. Therefore, this entire thing is now become true. It's a true statement, and true gets assigned into Boolean z. So whenever we call Boolean z, it will be a true statement. Now, if a is not a value equal to, let's say it's equal to 55 or 45, basically any number that is not 50, right? When we declare that and say, hey, is this number equal to 50? It's going to return false. Therefore, z will equal to false. Now let's look at the not equal operator. It's basically the complete opposite of the equal to operator. It basically says, hey, if this number is not equal to this number, then it's true. But if it is equal to that number, then it's false. So let's look at here. Let's say we declare integer b is equal to 60. 60 is not equal to 60. Wait a second. 60 is 60. So this entire thing becomes false. Basically, you can say that if it's any number besides 60, then it's true. So if integer b is like 61, 62, 63, any number that's not 60, then it's going to return true. So Boolean y will be true only if the number is, if b is not 60. Then we have either greater than, less than, greater than or equal to, or less than or equal to operators, relational operators, that you've probably seen in your math class. Now, in your math class, right, you've probably seen these, but you probably haven't seen this before. And the reason why is because we don't have a way of putting the line underneath the relational operator, or that alligator thing that you would think of in math, And instead, we just put less than or equal to like this rather than putting the line under. So for less than or equal to or greater than or equal to, we utilize 2 characters. All right, so let's start off with greater than. If Boolean x, if c, let's say if c is like 80, right? 80 is greater than 70. So that is going to return true. But let's say we put c as 50. 50 is not greater than 70. So that will return false, and x is going to be false in that case. But let's say if we have 70, well, it's still false because we're only saying, hey, if a number is greater than 70, if it's greater than 70, 70 is not greater than 70. So that will return false as well. Now, let's look at the less than. Let's say that D is 40. 40 is less than 80, therefore this thing will return true. But let's say if it's like 90. 90 is not less than 80, so this thing will return false. Let's say if integer D is 80 itself, right? Is 80 less than 80? No, it's not. So therefore, it will be false in that scenario. All right. Then we go on to greater than or equal to. So let's say E is equal to 95. 95 is greater than or equal to 90 because 95 is greater than 90. It crosses one of those over, so therefore it is true in that case. Let's say if E is 80, 80 is not greater than or equal to 90, so that's going to return false. Now I'm going to try something that I did with the last two and utilize the same number. So let's say if E is 90. 90 is greater than or equal to 90 because it crosses off the equal to one. So it is equal to 90, therefore it's going to return true. And then our very last relational operator is less than or equal to. So let's say if F is 50. 50 is less than or equal to 100 because it's less than 100, so it's going to return true. Let's say F is 200. 200 is not less than or equal to 100, so it's going to return false. So you would be false in that case. Finally, let's set F equal to 100. 100 is equal to 100 is equal to or less than or equal to 100. So therefore, if F is 100, then this entire thing becomes true, and then true is then stored within U. So that's a rough overview of our relational operators. So now let's move it on into the compiler. And I want to specifically mention about the equal operator because we can utilize the double equal sign for a variety of other functions besides numbers, including Boolean itself. So let's go into the compiler. Oh, all right, there you go. So let's start off with the easiest one, and that is the equal operator. So integer A is equal to 40. Then we do integer B is equal to 40. Then we declare a Boolean. Boolean X is equal to, and let's say A, oh, sorry about that. A is equal to B. So this is our relational operator. It's going to compare these two numbers together. Whether or not it's true or false, it's going to assign the value into X. And then to see what value it gets assigned, we're going to create a print statement that executes the Boolean value. So we get to see whether or not if it's true or false. So based on our knowledge, right, we know that integer A is equal to 40 and integer B is equal to 40. So when we call these values, it's going to be 40 is equal to 40. 40 is equal to 40. Therefore, it's going to return true. Now, the reason why we use the double equal sign rather than the regular equal sign is because the regular equal sign is used for assigning values. So when we're declaring integer A is equal to 40, integer B is equal to 40, we utilize the one equal sign because that is our assignment operator. But we want to utilize the equal sign as a relational operator. So we utilize the double equal sign in that case. So hopefully that will return true. And it does. Now let's try a number that is not 40. Let's try a number that's like 45. right? So now what happens is that A is now compared to 45. 40 is equal to 45. That's not true at all, so it's going to return false. And it returns false in that scenario. Now, what I'm going to try doing for this thing, just like what I'm going to do for the equals and the not equals, is also use a Boolean function or Boolean value to compare it. So the equals operator can also be utilized for Boolean values. So let's say I set Boolean A is equal to true, and then let's create a Boolean B that is also equal to true. So what happens is that Boolean X is now going to be a product, or not necessarily like a mathematical product, but like a product of the relationship between A and B. So we're going to access A, and it's going to be true. And we're going to access B, which is also true. So is true equal to true? True is equal to true, so this should print true. And we forgot the semicolon. And it prints out true. Now let's say if one of them is false. It prints out false because true in this case is not equal to false. So it prints out false. So now let's go into the not equals operator, and we're going to test it out with both integers and booleans. So integer A is equal to 50. Integer B is also equal to 50. Then we're going to do Boolean X is equal to A is not equal to B. Sorry, I just lost my train of thought there. Compile. Let's make sure that all our code works. And then run. And it's false. And the reason why is because it reads it like this. So A is 50, B is 50. 50 is not equal to 50. Wait a second. That doesn't sound right. 50 is equal to 50. So that's going to return false. But let's say if we put any number besides 51 for integer B. Besides 50 for integer B. So it could be 51, it could be 510, any number besides 50. And it's going to return true because it reads it as A is not equal to B. 50 is not equal to B. 50 is not equal to 51. 50 is not equal to 1. So that is true. It returns true in that case. Alrighty, let's try with the Boolean values. So let's say if I have both of them set to true, just like in the initial scenario where I had both set at 50. Compile, and then we run it. And it returns false, because just like the old scenario where it said 50 is not equal to 50, which is false because 50 is equal to 50, it reads it as true is not equal to true. And that statement just doesn't work because true is equal to true. True and true are the same thing, so it returns false. However, if we have false for B and we run it, it's going to return true because it reads it as true is not equal to false. True is not equal to false. That is a true statement. So it's going to assign a true into X. Alrighty, so now let's do the last 4 relational operators. Integer A is equal to, actually, let me first change the Boolean X. A is greater, so we're going to do the greater relational operator. So if we have integer A is equal to 50 and integer B is equal to 45, it's going to read it as 50 is greater than 45. Is 50 greater than 45? Yes, it is. So it's going to return true. And it returns true. But let's say if we do a role reversal on it. that is false because it reads it as 45 is greater than 50. 45 is not greater than 50, right? So it doesn't sit well with the system, right? It reads it, it says, oh, that's a false statement. 45 is not greater than 50. So it prints out false after it gets assigned to Boolean X. Now, for the sake of testing, what I'm going to do is I'm going to set a value for the same value to integer a and integer b. So integer a is going to be equal to 50. And it reads false because it reads it as 50 is greater than 50. 50 is not greater than 50, so it's a false statement. Alrighty, so let's move on to the less than sign. And just for the sake of testing again, let's try it with both values as the same thing. And it releases false because 50, it reads it as 50 is less than 50. 50 is not less than 50 because that's an incorrect statement. 50 is equal to 50, right? It laughs at that and it prints out false. This one releases true because it's like 45 is A, 50 is B, 45 is less than 50. Well, 45 is less than 50. It's a number that is less than 50, so it prints true. Now let's make a bigger number and rerun it. And it should be false because it reads it as 55 is less than 50. 55 is not less than 50. It's greater than 50. So this statement that we have here is false. Alrighty. So now we're going to move on to the greater than or equal to relational operator. And let's test this out. And it's true because 55 is greater than or equal to 50. 55 is just, you could say that 55 is just greater than, or you could say that 55 is greater than 50, but that would be completely missing the relational operator that's located here. We want to say it's greater than or equal to 50 because that's the relational operator that we have comparing those two values together. So it crosses off one of those criterias. Therefore, this whole statement is true and then assigns true into Boolean X. Let me change, let's make this 60. And this time it returns false because it reads it as 55 is greater than or equal to 60. Well, 55 is not greater than or equal to 60, so it returns false. Now, just like the previous two relational operators, we are going to assign the same value to integer a and integer b. And now let's see what happens. And I'm pretty sure you can guess what is going to happen now. Finally, we get true. And the reason why is because we included the equal sign after the greater than, or later on coming, the less than relational operator. So this says, hey, if a and b, we don't mind if a and b, a isn't greater than b, as long as it's a is equal to b, we'll still allow you to be true. So it's like, all right, 55 is greater than or equal to 55. Well, it is. It crosses off that criteria being equal to each other, so it prints out true. Similarly, it does the same thing when we change it to less than. So less than, it's still true because, well, we still have that equal sign there telling the compiler that as long as the two numbers are equal to each other, we'll still be true, we'll still print out true, or rather, we'll still assign the true to the value of x, and then when you call it, we're going to print out true. All right, let's make it 50. That should print out false because 55 is not less than or equal to 50. And then the last one should return true. And the reason why is because 55 is less than or equal to 60. 55 is less than or equal to 60. That's why true gets assigned into x. And when we print it out, it's true. That wraps up our video on relational operators. I hope you had a little fun. I know we haven't been doing that too much with the Boolean function, but we are going to be utilizing the Boolean value a lot more now with decision making and control structures. So stay tuned in for that. But for right now, I want you to practice relational operators and the future operators we'll be discussing in this course.